Hi. So I wanted to record a tutorial of sorts. Really, the inspiration from this was over the course of my career as a software engineer. I always had this temptation that when a new problem would come along, I wanted to use my programming tricks and all the skills that I developed to solve every problem. But more and more new problems would come up, and I'd end up with all these throwaway scripts and programs, things that just didn't end up getting used again. And I started to learn that there were tools that were already available on the computer that rather than designing a custom program every time, I could just use those tools and compose them together to make bigger solutions. And that's kind of what I want to share here. I was inspired to share it more broadly because I've run into more people who work in tech that have problems like this, and they may not know how to program, so they think that they're in a position where they can't solve these problems themselves, or they need to work with a developer to get some processing done. What I'd like to show you is that a lot of the things that you may need are already there and could be useful for you to solve some of these problems yourselves. So that's basically what I want to share. All the material for this will be here in this GitHub repository that I'll share with this video. But as you'll go through, you'll see there's instructions. All of the material for this presentation that I'll show are in this HTML file. There's instructions for if you wanted to view this locally on your own computer, how to get that done. And all of the examples that I'll show, all of the code lives inside of this repository as well. So there'll be instructions for how to download these things. There'll be instructions if you want to run it with something called Docker. You can also do that as well. And then you don't necessarily have to install anything. You just install Docker and then it sets up an image for you. So that's where all that is. And the rest will be either here in this presentation or we'll jump over to my shell, my terminal, to just show you the examples just live. So let's go ahead and kick off. So the title here is about CLI tools, and we're specifically focusing on CSV, JSON, and HTML. For those of us that work in tech, especially in anything that's facing the web or SaaS products, a lot of the data that we work with is encoded in a CSV format, or if you're dealing with an API, it comes across as JSON. For those of us that work a lot with web and web pages or multiple websites, a lot of data is just contained in the HTML just to understand what's on a page itself. So we'll be focusing on tools to help you deal with that kind of data. So like I was saying earlier, the things that I want you to be able to come away with is code is a very powerful tool, but it's not the only tool, and it sometimes isn't the appropriate tool for if the problem is straightforward enough. So a lot of the problems that you may be tempted to solve with code, and I'm speaking both to developers and non-developers alike. For developers, like when I started in my career, I just wanted to write a new program for everything, but it's helpful to grow in your career and having the awareness to know when code isn't the answer. And for folks that don't write software themselves, but maybe have been thinking about it or have been frustrated that they couldn't get forward, I want to speak to you as well. You should, still learn programming if you want to, but you don't always have to. So the other things that I want you to kind of take away with was there's this idea out there, we are aware of it, or call it the UNIX philosophy, and it's just this idea that you can take small existing tools and glue them together to make bigger solutions, and we'll talk about that too. And then I'll just show you a few of those tools. Some of them are probably already on your computer. Some of them are just things you can download and they solve a very specific problem. But at the end of it all, you'll kind of just get a small taste of what's possible, and hopefully that inspires you to learn a little bit more of this and go find out what kinds of tools are relevant for your problem space. So starting in, this is maybe a little bit of a reflection on my past and what really motivated and inspired me to learn more of this stuff. On a given day or week, I would get a request. Maybe it was from a friend on the sales team or someone doing, decision making and product management. But I'd get some kind of CSV, or from sales it would come from a client, and it was big and it needed a lot of processing. It might have involved pulling in remote data, so maybe data in a database or at an API, or if it lived in Salesforce. But all of the data that I needed wasn't in the spreadsheet. And then I had to process all of those and reformat it and save it again as a CSV and then send it back to the client. And even though as a software developer, I like solving problems like that. I was typically tasked with making, you know, a software to solve proactive problems, software that could scale and be used more than once. And, it just didn't feel like a good fit of my programming skills to the problems that we were trying to solve. And most of the time, these were pretty urgent. So I didn't have a lot of time to just write the most beautiful program and send it back, right? So I needed to be efficient. I needed to be able to move quickly. So yeah, we want to get to a place where we can field problems like this. We don't want our colleagues in other departments to feel, like they shouldn't be able to come to us, or they should be able to come to us for help. So we want to be able to get to a point where these are just easy to solve and we can get them done. So like I said, in the beginning of my career, I was mostly working as a software developer, and now I spend more time as a product manager. And yet, when we're making good decisions, we usually have data to help us make those decisions, and that data can live in all different kinds of formats. Most of the time, the problems are very unique, which is to say, I've solved problems for a customer, for a client that I just never saw again. And that meant that, it needs to be okay to throw away a script once we're done with it. So if we don't have those tools, we do have to end up writing custom programs, or you might have to resign yourself to learning Python just so you can get through a log file or something like that. So that's not where we want to be. Instead, we want to be in a point where we're not frustrated for just being stuck and having to write new programs. Instead, we want to be able to get to a point where we can use the tools that are already on our computer, that we don't have to be limited just because we don't know programming, or we do know programming and don't necessarily want to spend that time solving for single use problems. So this is the UNIX philosophy, and you can read through this, and it would be just as easy to find this. And in fact, in the deck, you'll be able to open up that URL. But it's just this idea that we should have a lot of different programs that solve one thing, one problem, and does it really well. And it has some preferences over how programs receive input and how they send input back out, or output right back out rather. And this notion also that if every program is communicating via text as an interface, we should be able to communicate to these other programs in a standard way. So if it isn't already obvious yet, the big moral here is don't write new programs to solve problems. Compose existing problems to solve problems, and we can create solutions from those existing programs. So if you're not already a developer or somebody who works with web servers or works in kind of more technical tools, you'll need a program on your computer called a terminal, or a terminal emulator. But the whole idea here is it's giving you a window into a part of your computer where you interact with a program called a shell. And that shell is basically what receives your commands. It lets you work with files, and it sends commands and deeper operations to the operating system on your behalf to run them. All right. So if you're on a Mac, you should already have a program called Terminal installed, and that will let you do all of these things. I regret to say I haven't worked in a Windows environment in a pretty long time, but I do understand that Windows Subsystem for Linux would be a tool that you could use to follow along, and comes with a lot of this. PowerShell, back when I did work with Windows, different commands but similar ideas. And I'll be running this presentation on a Linux device, and so if you're on Linux, you probably can find your way to a terminal program as well. But you'll need one of those to follow along and do these things yourselves. So let's talk about some of the tools that are already there. So Mac OS X and Linux, they both are inspired by Unix, which is it's where a lot of these ideas came to the forefront, and you don't necessarily need to know the history of Unix. Mac, I believe, uses an operating system called Darwin, which is based on Unix. But either way, what makes them POSIX compliant, what makes them behave in a similar way, is that they have a lot of these tools here that just are kind of expected to be in that operating system, in that environment. So some example of tools that I use really regularly, cat, short for concatenate. It just prints contents of one or more files out to the output. There's grep, I believe that stands for global regular expression and print. And that's basically you give it a pattern and you just give it a stream of content and it will find things that match that pattern. And so that's useful for maybe filtering or looking for lines that contain specific text, that kind of thing. awk is another useful program. I use it a lot for, it can do filtering as well, but it processes text. It can extract things out. It can report them back out to the screen. Curl is really helpful if you do a lot of web requests or HTTP requests rather. If the thing that you need can be accessible via HTTP or HTTPS, you'll probably use curl. And unique and sort, they work together really nicely. Sort should be pretty obvious what it does. Unique is nice because it can remove duplicates, or you can have it group and count. And those are pretty handy to do. So there's a lot of tools out there, and what I would recommend for you is not try to learn every Linux or OS X command under the sun. Instead, maybe pick like 10 to 15, just a good place to get started, very common tools that you'll end up using. These links down here just are good examples of pages like this where they just say like, hey, if you're a software developer or an SEO or a marketer, like here's some great CLI tools to use. And it will also help you discover new tools that are specific to your domain and might be more interesting to learn. So the last link here, though, is an example for how to use manual pages. So that's what man is short for. And that's a great way because most tools ship with their own documentation as well. So whenever you install one of these command line tools, they will install then their documentation to the manual pages that live on your computer. And that's a great way as well to learn how your tools work locally. So I mentioned earlier the notion of something called a shell, right? And there's different kinds of shells, but its role is to let the user interact with the computer and issue commands back to the rest of the computer on your behalf. But it also lets you connect programs together. And so we have this notion of piping. Oh, there's a typo here in my presentation, but it has this notion of piping. So any given program will read on, it expects its input for something called standard input. So that's references standard in. You'll see this later in the deck. So I just want you to get to know that that's what that means now. Standard in is where a program expects to read by default. And then standard output, I really messed that up. Standard out is where it expects to write. And for by default, the file or the place where it expects to write is just back into your shell or back into your terminal. So when you run a program to say a word, it will just print it back out on the shell, and that's called standard output. What's cool is that the standard out and standard in can be redirected. So that is to say, rather than printing to the terminal, maybe a program can print to another program, and you can connect the standard out of your first program to the standard in of your second program. And we'll see what that looks like. So we've got a couple of examples here. We'll switch over to code. The first one is just about looking at web server logs. And then the next one here will just be looking at the command line history that your computer saves, just to show what the most popular commands are on your computer. So let's come back over here. I've got all of the code in this repository living right here. So we're going to go into the bash folder and we'll start by looking at this parse server logs file. So in here, there's just a bunch of, if you spent time on this on your own, this would just explain what's going on and what the point of this is, if you weren't doing it with me. But what we have here is just a little script. We take in, there's two popular web servers that I'm aware of that I think a lot of people use. There's Apache, which is an open source web server, and Nginx, which is another popular open source web server. And this is relevant to you if you work in a non-Microsoft environment and let's say, something like maybe use WordPress to run your website or something like that. So your web server is still logging everything that it encounters, all of the requests that come in, all the errors and so on. You might want that to see what are some common errors or what traffic am I getting to pages that are dead or not existing. That's the kind of thing we can look at. So we're going to borrow from this line this is an open source project here by the Elastic company. and they maintain a lot of examples of log server files. So this just gives us some sample data to play with. So we have in our script, we can either use Apache format or Nginx format, or we complain if we don't recognize what that is. And now we'll get to the part where it's more interesting. So we have a few common tasks like getting raw logs, getting the user agents. So these are just names to examples that I've given. What we're really interested in is these programs down here. So the very most simple one is we define which URL we're using based on the format up here. And we're going to run the curl command. This -s here are flags or arguments that can change the behavior of how that program runs. So -s means silent, be quiet, because normally it spits out a lot of information about its own progress. And then this $sign here is we're giving it the variable, right? So we assign its URL is going to be one of these two lines. And it's just called a variable, so we pass the value of this variable into this program, and that will print out the raw logs. And so if I come over here to another window and go to my examples folder, so I can do for, again, on these shells, if I do // that means run this program or run this script. So let's parse our server logs, and we'll ask for Apache, and we'll get raw logs. And it prints out a bunch of stuff. Here, let's zoom in on that. So that's kind of a mess. You probably don't always want to work with all of this data all at once. There is a program called head, which would just take, the first some number of lines of any given stream of text. So remember how I said earlier we can pipe things? So by default, this program is printing all of its output to the shell like we just saw. Instead, I want to print that output into head, and that's what this pipe symbol does for me. It's going to turn the output standard out of parse server logs.sh to standard in of head. And I can give it -n, which is the number of lines, and let's say I just want the first 5 lines of a file. And that does it, and that just gives me the first 5. There's a similar program called tail, and that will give you the last 5 lines of the file. And tail can also be instructed to follow, and that's useful for live running logs, for example, and if you just want to watch the logs as they come through. But the whole important part was we can pipe and connect these programs together because they do simple things. So let's do something a bit more interesting. So here, if we wanted to look for the user agents, what we can do is, let's look again at a few lines of the file. So this is a format that Apache logs to, and we see, in the first line there's the IP address, and then these appear to be maybe blanks or placeholders. There's the date. In between the quotes here, there's what the request was and what page it came to. Over here on this line, we have the user agent of who made the request. So this is the format that we have here. Your web server might be configured to log things differently, or maybe you have a web server that isn't Apache or Nginx. But we have this program that can extract text. We just need to tell it how to break up the fields and how to pull out which field that we want. And so awk lets us do that. So what we're going to do first is we're going to do the same curl command that we did earlier. And then we're going to pipe it into awk. And so we're going to tell it -F that the field separator, and so field separator would mean, like in a CSV, the field separator is the comma. And in JSON, the field separators are like the quotes and colons and curly braces. Don't worry if you don't know what that is. We'll get to it in a little bit. But basically what we're saying here is break up the line using quotes as the field separator, and then print the 6th column that comes out. Right, and so if we do that here, let's see, I'll do it like this, and I'll comment all of these out. And a comment just means it's something that we will read, that humans will read, but the shell will not. It just ignores them. So if I do this now and I say raw logs, and instead I want to change it to parse server logs Apache and get the user agents. So right now this is just going to print the 6th field, and I got to get a whole mess of stuff. So that gives me a lot of raw user agent lines, right? Only the user agent out of each line. But what I'd like to be able to do is count them. So then that way we get a good sense of which kinds of user agents or browsers are people coming to use to view my website. So I can do get out the sixth field and get my user agent that way. Then I send the user agents to sort. And sort is useful to run right before unique because then that lets us dedupe and count. So unique will normally drop the duplicates and just print out all the files removed of duplicates, but -c will count them. And then if I want the, want the most frequent ones first, I can sort it in reverse order. That's the -r here. And one thing to note is that we can combine single letter flags. So that's why it says -nr. So I'm going to sort. N is going to let me know that we're sorting by numbers and not by alphabet, and that's useful in some occasions. And then R says in reverse order it so that the higher numbers come first. And then I just want the first 10. So again, this is a larger solution that we've used by just gluing together a few of these little programs, right? So if I run this again, I'm just going to get those first 10 lines, and if I zoom in, we can see that this first line, out of all of the logs, over 1,000 of them came from this user agent. And this is useful for folks like, let's see if, like Google lives on here. So I can do the same thing in grep, and I will do -i to ignore the case and search for things that say Google, and I can see which Google user agents are hitting my website. And that's useful for certain kinds of scenarios. The other thing we can do, I guess it would also be helpful to show off. I mean, this is, you're probably not at the point where you want to write too many of your own shell scripts, but I can do the same thing with Nginx, for example, and just change the argument. And this is a different log file, and I get different answers, right? So I can use the same program for different kinds of formats. Anyway, another use case that we had was we wanted to see what the 404 pages on my site might be. So like, let's look at parse server logs again. We'll do Nginx this time. And I'll write 404 pages. So what this is doing now is it's going through and finding all the pages that my web server is reporting. I'm getting requests for these pages, but we don't have this server, we don't have this page on our server. We don't know what this is. Let's look at the same thing for Apache maybe. Yeah, so like someone is asking for, I haven't looked at this before, but someone is looking for some GIF that used to be on our website and it's not there now, right? And this could be useful, especially if you're not aware that a page is broken, or maybe this means that somebody has a link to your website that isn't there anymore. But breaking this program down, here what we're doing instead is we're separating still again by the quote field, or the quote character rather. And then there's this line in front here. This between the slashes says I need to see in each line a space and then 404, and that's the server code for file not found, and then another space. So this needs to exist somewhere in the line. And then if this test here, so from here to here is a test, so if that test is true, then I want to print out the second field. And then this sequence here is just the same as it was before. So the only thing that we've changed is we've extracted something different and we added a filter. And so that's what lets us get these 404 pages that way. The other thing we can do is use a separate command for filtering, right? So awk has a structure for filtering. I don't always write my filters in my awk programs. Instead, what I'll do is I'll use a program called grep. And so this is a little bit fancy. So this $3 means the third argument to the script. You don't have to learn that. Don't worry about that right now. The point isn't to learn shell scripting. But what we're going to do is let's go back to our Nginx example. Here, let's zoom in again. So what we see is we've got a lot of requests to some product page that doesn't exist anymore. So I'm going to copy that. And instead I'm going to write requester for page, right? So let's do script parse server logs nginx requester for page, and then the page that I want to look for is that. So that's running now, and it's telling me the IP addresses of all of the all the traffic that's coming to this broken product page, right? And the way that I'm doing that is I'm using grep, and so that $3 is being replaced by this downloads product one string. and then it's basically then taking this original log file, filtering it down to only the log entries that have that page in it, printing out the first field, which was the URL, and then we're doing our sorting and counting, right? So that's just an example of, we can glue all this stuff, and we haven't installed any new programs to do this. Curl, grep, awk, on most systems, those should all just be there. And we can just solve pretty flexible, complex tasks just by using what's already there. These examples will be available for you to download, so you can like pick them apart later if you want to. This script is maybe a little bit more complicated, only because we're dealing with two different history file formats in the same script. So what I'm doing here is first I'm doing a test to see what kind of shell you're using. So on my computer right now, for example, if I echo this shell variable, I'm using Z shell. I'm comfortable enough with my programming environment to know that I prefer Z shell. But Bash is already very common and available on almost every server I've ever logged into. So what we're doing here is we're just looking to see if the user is using Z shell right now, and if so, we'll default to looking in a file called bash history. Otherwise, we'll look in a file called Z shell history. And these both have different formats. And so like for an example, so I'll use that cat program I mentioned earlier. And I've got my bash history file here. And you can see it's a log of every command I've ever run on my computer. If I do the same thing with my Z shell history, you can see that they look different, right? There's a timestamp in here that uses colons and semicolons. It shows a lot of arguments. So we need to be able to deal with both, right? So if I'm dealing with bash, I just want the first field. If I'm dealing with Z shell, I want the fifth field, but the fields are formatted differently. If you remember, bash just had spaces, and but Z shell had colons and semicolons and spaces. So I'm telling awk, these are the different ways to identify the fields. So depending on which history file we ended up with, I'm going to print out, basically extract the command from my history, and then do my sort and count. And I'm just going to get the most popular 30. So let's run popular commands. And on my computer, I use the ls command to list the current directory. I use git a lot. I use, yeah, that's what I use on my computer. So a silly example, but it's just kind of how you can take this same patterns, just extract, organize, count, report. Like that's a pattern that you'll probably run into a bunch. And so that is, that's just an example of how you can get a lot of that done just with what's already on your computer. So the next thing that we'll end up talking about is other programs that have been written and that exist to help you kind of move through different kinds of formats. So for example, JQ is a program that works with JSON, and JSON is a file format that's, it doesn't work like a CSV might, where all of the commas are in an expected place. Like you can use commas and values in JSON. Pup is good for working with HTML. csvkit is good for working with CSV. It's a really powerful suite of tools. But the whole point here is that, I call this Buy Nothing. I was kind of borrowing from the neighborhood groups that we have where people give away things that they don't need and can ask for help from the community. All of these are open source. You're very welcome to support and donate to the authors of these programs. But what's neat about open source is, that expectation isn't there. Like software should be free and ideas should be free to people who subscribe to those beliefs, that is. But that's something that you should expect out of just open source and free and open source software. There's probably a program that solves your problem in your space. So this has been about 30 minutes of just getting through the basics. And the next video I'd like to record is just how you can use these programs in a few example contexts. And then we'll eventually get to a point where we tie everything together in just a big contrived example. So hopefully this first 30 minutes was useful. Stick around for the next video. We'll just to break the content up a little bit. We'll talk about these new programs and how to stuff them all together. So thanks for watching, and I'll get the next one up pretty soon.